Now, a very useful application of linear algebra. Okay, that's a little better. We have the points 4, 0, negative 2, 5, and 0, 3, which I've plotted here, here, and here. At least I've marked points in the plane to represent these points. Okay? And we want to find the values of A, B, and C so that the equation y equals ax squared plus bx plus c has a graph that passes through these 3 points. Okay, and it's actually fairly easy to do this. You have to know what to do though. So, well, if y equals ax squared plus bx plus c, then that's going to be true for the x and y coordinates of any one of these points. If the graph passes through all 3 points, then, for example, when x is negative 2, y has to be 5. When x is 4, y has to be 0. When x is 0, y has to be 3. Well, let's first look at the middle point here. Okay, I said when x is negative 2, y has to be 5. That means if I plug negative 2 in for x and 5 for y, I get a true statement. So plugging those coordinates in, negative 2 for x gives me a times the square of negative 2. And bx is going to be b times negative 2. Now c is just c. There's no coordinate associated with c, but over here we've got y, and that has to be 5. So there is the equation that corresponds to this point given this form of the equation. And that equation can then be rearranged. Negative 2 squared is 4, so we have 4a. Now I wrote the 4a here. And negative 2b and c, and I put the 5 on the other side because that's the order in which an equation would usually be written. The point 4, 0, well, y is 0, so it's going to be equal to 0. I'm going to put 4 in for x, so I'm going to have a times 4 squared, which is going to give me 16a, b times 4, which is going to give me 4b, and again, c is out there, and I've got that. And then the third point, 0, 3, all the x's are 0. So I'm going to have a 0 here and a 0 here, a c here, and y is going to be 3. So I'm going to get 0a plus 0b plus c equals 3. Okay, well, I can solve these 3 equations for the variables a, b, and c. And having done that, I can put those numbers into this equation with the assurance that when I put in 4 for x, I'm going to get 0 for y, which means I'm going to match this point. When I put in negative 2 for x, I'm going to get 5 for y, which means I'm going to match this point. When I put in 0 for x, I'm going to get 3 for y, so I'll match this point, and the graph of this function here will pass through those 3 points. Okay, well, I write down the augmented matrix, and that's very straightforward. I'm not going to read that to you. I write down the augmented matrix, then I try doing calculations in my head to reduce it, and I don't think I reduced it successfully, and I'll tell you why, and I'll recommend that you reduce the equations yourself and see what I did wrong. C was smudged very badly. I wanted to fix that. Okay. So first thing I did, I divided the first equation by 4. I multiplied it by 1/4. Okay. I got this. And then I went ahead and used that, because I'm kind of shortcutting things a little bit. You really kind of want to do that in 2 steps. But I used this to reduce, to get rid of the 16 here, and I got this. Okay, so I kind of went through this fast because I know you know how to reduce equations by this point, and if I'm wrong, then you really need to go back and learn to reduce equations. Okay, this is something that we're kind of past now, so be sure you can do it. And then I divided this equation through by 12 and got this, and so far it looks like I'm okay. And then the third equation was very easy, so I had that. Now at this point I could have used back substitution, and probably should have, because I went on and dealt with all these fractions and messed something up. I don't know what it was. But just to show how I proceeded then, I wanted to get a 0 here. So I took half of this row and added it to this row. So a half of 1 is a half, plus a half is 0. Half of negative 1/4 is negative 1/8. Add that to 1/2, you get 3/8. Now, what I do here? Half of negative 5/3 is negative 5/6. 5/2 is 15/6. And negative 5 and 15 is 10, not 9. So that should have been 10/6. So the 3/2 here, already there's a mistake. That 3/2 should have been 10/6, which is 5/3, which actually would have been a little easier to reduce. So that's kind of wrong. Not just kind of wrong, it's plain wrong. And then I took 3/8 of this row and added it to this, which would have been okay if this row had been correct. And maybe I did that accurately, and maybe I didn't. And I got these solutions, okay? And, you know, it just, yeah, plain not right. But anyhow, if this was a solution, this would be my equation. Now, fix it, you know. Then verify is the graph of this equation matches this picture where the graph goes through these points. What is the graph of this equation? What kind of a shape do you get? Well, you should know from pre-calculus, and if you've had calculus, you should absolutely certainly know this is a degree 2 polynomial or quadratic polynomial, and its graph from calculus you should know that the graph has one extremum. That would be what we call the vertex of the parabola that's formed by this equation. Also, you should know that the, and I'll write this down as kind of an extra, the quadratic formula y equals 0 if and only if x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, quadratic formula. Also note that negative b over 2a is right in between negative b plus this thing over 2a and negative b minus this thing over 2a. So that this is where the axis of symmetry for the parabola is going to be. So the axis of symmetry is at x equals negative b over 2a. Well, if we do negative b over 2a, we get 11/12 over something like about 5, so we get a small fraction, which means we have an axis of symmetry that's much closer to 0 than this point, and that just doesn't work. Clearly I solved the equation wrong. And that's the kind of thinking you want to do. You solve the equation, you get this graph, and you ask yourself, okay, does that graph make sense? Well, the axis of symmetry alone tells me that no, it doesn't. So getting a 5/3 in here might help some. But correct me and see if you can get an equation that has a reasonable axis of symmetry. Doesn't have to be where this one appears to be. That's certainly probably not the vertex. But solve the equation, solve the problem, match it up.